we move to linear programming or operation research. So we start with the definition. Linear programming is a mathematical modeling technique in which a linear function is maximized or minimized when subject to various constants. So the goal is to maximize or minimize objective function with the presence of various constraints. Okay. We do only a modelization, then we enter the site of PHP simplex to get the results of or the optimal results for the problem, optimal solution for the problem. Okay, now we have an example here. As the Easter approaches, an artisan chocolatier decides to make chocolate eggs. When he went to inspect his reserves, he noticed that he had 18 kg of cacao, 8 kg of hazelnuts, and 14 kg of milk left. It has two specialties, the extra egg and the sublime egg. An extra egg requires 1 kg of cacao, 1 kg of hazelnuts, and 2 kg of milk, while a sublime egg requires 3 kg of cacao, 1 kg of hazelnuts, and 1 kg of milk. He will make a profit of $20 by selling an extra egg and $30 by selling a sublime egg. How many extra and sublime egg must he take to make the greatest possible profit? So when we talk about make the greatest possible profit, we talk about maximizing the benefits. Okay, so not minimizing, but maximize. The objective function is to maximize the benefits. So we start with the first thing. The first thing we should do is to modelize the problem. Let's take the decision variables. Decision variables. We start with the decision variables. Okay. We have. Let's call for x the number of extra egg produced. And for y, the number of sublime egg produced. So now, as we we define the decision variables. The second thing we're gonna do is make the economic constraints. We'll start with the cacao. We have a reserve of 18 kg. Okay. The thing we should define is that the extra egg require 1 kg of cacao. Then for the sublime egg requires the sublime egg requires 3 kg of cacao. Okay. So that means if we want to produce one egg, we require one extra egg. We require 1 kg of cacao. To produce a sublime egg, we require 3 kg of cacao. Okay. That means x plus, so 3y should be, it should be inferior to 18, the number we have left, to 18 kilograms. Now we move on to hazelnuts. extra egg require 1 kilogram, and the same thing for sublime egg. That means x plus y should be inferior to 8, because we have 8 kilogram of hazelnuts. So for the milk, as you know here, the extra egg require 1 extra egg require 2 kilograms of milk, and for the sublime egg it require 1 kilogram of milk. No, extra egg requires 2 kilograms of milk, and one sublime egg require 1 kilograms. That means let's type it right there, x plus 2y, 2x, because the extra egg requires 2 kilograms of milk. 2x plus 1 y, because sublime egg requires only 1 kilogram of milk, should be inferior to 14. So now we move to the third step, which is define the objective function. Okay? So to maximize the benefits, that extra egg make $20 profit, and sublime egg make $30 profit. That means define objective function with that equal to 20x number of extra eggs are produced, plus 30 multiplied by y, which is the sublime egg produced. Now, as we define all of this, that we write the mathematical problem associated. So to do that, we're gonna move to a famous site to do it, which is called PHP Samplex. So the method, we have Samplex 2 phases on graphical. We're gonna explain that later. How many decision variables are the problem? We have two variables, which is sublime eggs and extra eggs. The constraints we have is we have 3 constraints: the number of kilograms of cacao left, number of hazelnuts left, or the milk left, and for every variables, how many that requires. Extra egg require 1 kilogram. Okay, for this for require 3 kilogram for cacao. 3y should be inferior to 18. Now we know that we have 3 constraints. Now x1 and x2. Let's just to remind this, for the sublime egg we take y, but here in this example for sublime egg we take x2, no problem. This is the objective functions. So the objective is to maximize the profits. We know that the extra egg make $20 profits, and the sublime egg make $30 profits, multiplied by the number of extra eggs and the sublime eggs produced. The constraints: how many kilograms of cacao for the extra egg required? It required 1 kilogram, or for the sublime egg 3 kilograms. That means 1 and here 3 should be inferior to 18 kilograms because we have 18 kilograms of cacao left. For the hazelnut, the same thing. X plus Y should be inferior to 8. And for the milk, 2x plus y should be inferior to 14. Okay, now this is the problem. Now we have make the problem. Now we get the results. The results: how many, how many extra egg in the sublime egg produced to maximize the benefits. We'll continue to know the solutions. The optimal solution value is we make a profit of 210, which is we're gonna, for x1, we're gonna produce 3, for other extra egg, we're gonna produce 3 eggs of extra egg, and for the sublime egg, we're gonna produce 5. Okay. So that's the whole idea behind the operation research or linear programming. Now we're gonna talk about it later when we go to further in the reporting and the analysis of example we take for actions of stock market. Thank you for your listening.